Okay, hello Mangotsfield School. This is Mr. Radmore, and this lesson is for Year 9 and Year 10, and it is a revision lesson on the wave equation. So here is your driving question. If you can write that down, please. And then for your starter, pause the video and have a look and identify which two letters are showing the wavelength of this wave. Okay, so the wavelength is the distance from one part of the wave to the next part where the wave starts repeating. So that's going to be F and B. Now, an easier way to remember the wavelength is simply the distance from one top bit of the wave called the peak or the crest to the next peak. Okay, that's our wavelength. Right, so let's just quickly recap on what waves do. Waves carry energy from one place to another. They carry that through vibrations. Okay, waves are very important. Two very important examples of waves. Light waves, so light energy is carried through light waves, and sound energy is also carried through sound waves. So here is a wave. It's a transverse wave. It's like a water wave. Here you can see the water particles vibrating at a right angle to the direction that the energy is moving. So the wavelength is the distance from one peak to the next peak. If I increase the wavelength, look, distance gets bigger. If I decrease the wavelength, that distance gets smaller, look. Okay. Now, another important part of a wave that we need to be familiar with is the frequency of the wave. The frequency is how many waves are passing by per second, or how many vibrations, one complete vibration there, look, happens per second. So at the moment, this wave has quite a low frequency, but if I increase the frequency, now you've got a lot more, many more waves passing by per second, many more vibrations per second happening. Okay, so wavelength and frequency, two important parts of a wave that we're going to talk about today. Okay, so wavelength is the distance from peak to peak, top bit to top bit, and it has a symbol which is the Greek letter lambda, which is basically an upside down Y. Okay, and the unit, because it's a distance, the unit of the wavelength is the meter. Okay, now frequency is the number of waves that pass by every second, or the number of vibrations there are per second, how many times a particle vibrates, and the unit of frequency is the hertz, and shortened to a capital H and a Z. Okay, so very quickly, what we just talked about, let's sum up. Pause the video and have a look and see if you can identify which of these is false, which of these is a porky pie, which is East London slang for lie. Okay, did you spot it? So, yeah, it was D. So far, the wavelength is the distance from one peak to the next peak. That's good, that's correct. Frequency is the number of waves that pass by per second. That's correct. The unit of frequency is the hertz. The unit of wavelength is the meters. Good. If 10 waves pass by per second, the frequency is 10 hertz. It wouldn't be 10 meters because hertz is the unit of frequency. Okay, so let's move on and let's talk about the speed of a wave or the velocity of a wave. So wave speed and wave velocity both mean how fast the wave is going. We will use the word velocity in this lesson, but which is the vector version of speed. But pretty much it means that they both mean the same thing in the context of what we're talking about. Let's look at a wave that has a wavelength of 1 meter and has a frequency of 1 wave per second, 1 hertz. So how fast would that wave be traveling? Well, if it travels 1 meter every second, it would be traveling at a velocity of 1 meter per second. So the wavelength and the frequency combine together to give you the wave velocity, how fast the wave is going. Okay, so that would give us 1 meter per second. So frequency and wavelength combine together to give us the wave equation, which is basically how to figure out, how to calculate how fast a wave is going, the velocity of the wave. Now, units wise, the wave speed is measured in meters per second. Frequency is measured in hertz units, and the units of wavelength are meters. Remember, symbols wise, V for velocity, F for frequency, but rather annoyingly, the symbol that we use for wavelength is a Greek letter lambda. It's an upside down Y. Okay. And if you wanted to put this equation in the formula triangle, there it is there, look, with V at the top, F and lambda. So you could cover what you want to calculate, and the remaining two would give you the equation. So velocity equals frequency times wavelength, frequency equals velocity divided by wavelength, and wavelength equals velocity divided by frequency. Now, a reminder of units. The units that we need to use for the wave equation: meters, hertz, and meters per second for wave velocity. So remember, if it's in centimeters, you've got to turn it into meters. So 100 centimeters equals 1 meter. If that little K there stands for kilometer, K, which is always 1,000, so 1 kilometer would be 1,000 meters. And if you come across kilohertz, which is a fairly common unit for electromagnetic waves, then that K again stands for 1,000, and it's going to be equal to 1,000 hertz. Okay, so very quickly, let's just have a think about how we can use the wave equation. Pause the video and tell me, what would the velocity be of a wave with a wavelength 3 meters and a frequency of 5 hertz? So 5 waves passing by per second. Did you get it? So it would be 15 meters per second. Right, let's bring in those units there. So what about if the wavelength was 50 centimeters and 10 hertz? What would the velocity be? Pause the video. Right, so remember, wavelength has got to be in meters. So 50 centimeters divided by 100 would give you, this is going to be 0.5 meters. So it's going to be 10 times 0.5, and that would give you 5 meters per second. Okay, so very quickly, so we are using an equation, and when using equations, you need to make sure you're showing your workings correctly. So let's take this example question here. Think about how we're going to show this answer. So firstly, for this question here, write the equation you're using. Always start with that. Write the equation. In this case, we've got the wave equation here. Okay, then put the numbers in. So the wavelength is 10 meters and the frequency is 5 hertz. So we put the numbers in, and then finally write the answer with the correct units. So for example, here it would be 5 times 10, 50 meters per second. That's the velocity of the wave, how fast it's traveling. And make sure you're using the correct units. Okay. Now, what about if you're not calculating velocity? You've got the velocity already. In this case, you need to change the equation round a bit. So here, look, you've been given the velocity of the wave and the frequency, but now you've got to work out the wavelength. So showing your workings for this, okay, write down the equation you're using. Then again, put the numbers in. You might hear my family in the background having a bit of a squabble. Please ignore them. Put the numbers in. Okay, so that's 15 equals 3 times something, and that's something that we need to work out. Put all the numbers onto one side. So you can do, if you've got a 3 on this side and the unknown, you can put that 3 onto this side. Because it's times by 3 on this side, it's then going to turn into divided by 3 on that side. So all the numbers go on one side, and then you can get your answer with the correct units. There you go. 15 divided by 3. The wavelength for here would be 5 meters. Right. Okay, so time to have a go at using these ideas. So for describe, you need to write down for me the symbol and the unit for each of those 3 quantities that we've been talking about. For explain, you need to use the wave equation to calculate velocity. For use, you need to convert units and then calculate velocity. And then for combine, you need to change around the equation and convert units to find out the wavelength or the frequency. Okay, so just pause the video and have a go at that. Okay, let's go through the answers. So in terms of velocity, the symbol is V and the units are meters per second. In terms of frequency, you should have got hertz, and the symbol for frequency is F. And then wavelength, it's that Greek letter, isn't it? Lambda, upside down Y, and the units are meters. Now, a sound wave, 3 meters, frequency 4 hertz, you multiply that together, you're going to get 12 meters per second. Okay, a Mexican wave, which is a wave, you've got football or rugby supporters vibrating the right angle to the direction of the energy. 20 hertz and 20 meters, that's going to be 400 meters per second, making sure that you're putting the correct units with your answer. Now, a water wave, 50 centimeters. So we need to turn that into meters. 0.5 times 40, that's going to be 20 meters per second. A slinky, again, look, there's that 10 centimeters. So you need to turn that into 0.1 meters. 10 divided by 100 equals 0.1. And that's going to also have, so 0.1 times 40 hertz, you're going to get 4 meters per second. And then in terms of an earthquake wave, wavelength 1.5 kilometers, frequency 1 kilohertz. So look, you've got a kilo there and a kilo there. So it's going to be times 1,000 times 1,000. You're going to get 1,500,000 meters per second. So changing the equation around, a water wave, velocity 6 meters per second and 2.5 kilohertz. So again, that's 1,000. You should have got 0.0024 meters. An earthquake has a velocity of 15 meters per second, frequency 2 hertz. So again, changing that around, you should have got 7.5 meters. And then a slinky wave, 2 kilohertz. What's the wavelength? You should have got 0.01 meters. Okay, so let's sum up, please, like we normally would do in our science lessons. Can you copy and complete? Did they have achieved a describe, because you can identify units and symbols for the wave equation? Explain, because you can recall and use the wave equation to calculate velocity. Use, you can convert units to standard units and use the wave equation. And combine, rearrange, and use the wave equation. Again, with converting units. So write that down, please. Okay, so I thought this was at the end of my lesson. I thought I'd include it just to try and bring everything together. This is called odd one out. So for number 1, number 2, number 3, number 4, for each one, you've got to guess what I chose to be the odd one out, which one doesn't fit in with what the other two have. Okay, so pause the video, 1 to 4, write down which one is the odd one out and see if you get the same 4 as mine. Okay, so for velocity, wavelength and amplitude, I think the odd one out here is amplitude, because amplitude of course isn't in the wave equation, but velocity and wavelength are. For number 2, I picked frequency, because frequency is in the wave equation, but the peak of a wave and amplitude aren't. For number 3, second isn't a unit that we use in the wave equation, but hertz is. It's in frequency, and meters per second is. And then for number 4, meter is the standard unit for wavelength. Millimeter and kilometers have to be converted. Did you get all 4? Of course you did. Okay, so now you've completed the lesson. You can attempt the Show My Homework quiz, please, and then enjoy the rest of your day, Mangotsfield School.